All right, so continuing on in chapter 2. So this first part says, think about the problems you have worked on involving positive and negative numbers. How would you find the answer to negative 200 plus 14? Without using your calculator, find the sum, explain your reasoning. I'll take a volunteer for this to explain how you do this. Yes, ma'am.
So since it's negative 200, instead of like adding it, like it would go up, like negative or negative 214, it would go 109, 186.
Okay, so tell me, how did you get 186?
Because kind of because it's below zero, so like you're trying to add it back up.
All right, so but specifically, what did you do to find 186?
Subtract.
Yeah, you're just subtracting. If you take 200 minus the 14, we get 186. Now, is my answer going to be positive 186 or negative 186? Yeah, it's going to be negative 186. So, how do we know that this is going to be negative instead of positive? Someone else. Yes, Isabella.
Because the negative 200 is like the number, the bigger number that has the bigger number, whatever is signed, the bigger number is what is negative.
Yeah, there's 200 is way bigger than 14, right? So there's way more negative than there is positive. So this has to be a negative answer. The way that I think about it, and maybe this will be helpful to you, when I'm adding a positive number and a negative number, they're working against each other. One wants it to be positive, the other one wants it to be negative. Who wins? Well, whichever one is stronger, whichever one has more. And the reason why we subtract is because they are working against each other. Okay? They don't combine, they work against each other. All right, so let's see how we're doing on these down here below. Well, let's use my random number generator to get some people for this. All right, who's in desk 10? 8, 9, 10. Oh, that's Nyla's desk. So we'll skip that and go to 5. Garrett, what'd you get for A here? Negative 50. And we're going to just go through these, and if they're correct, we'll just move on unless someone has a question or disagrees. So anyone disagree with this? All right, let's see, desk 1. What did you get for this?
I got negative 90 and 7/8.
All right, anyone disagree with that? Okay, I don't disagree with that either. Then let's see, thank you, sir. Desk 15, Aiden. And if we get to one where you're like, I didn't get this far, that's fine. Did you get to this one?
Oh, yeah.
Okay, great. What did you get?
I got negative 56.22.
0.22? All right, is there any disagreement on this one? There's some minor disagreement. What did you get?
I thought we would change it to a positive number.
All right, so at some point, unfortunately, math teachers have a bad habit of saying things like this: 2 negatives make a positive, which is just dumb. It's not true all the time. When you multiply 2 negative numbers together, you get a positive. But if you're adding 2 negatives together, they're working together. So it's just more negative. So it's negative 56.22.
Because of the
Oh, the parentheses? So the parentheses around this is just so we don't have, if we didn't write it with that,
Oh, because it's in my bad.
students write this sort of thing all the time, and I'm like, are we adding or are we subtracting? What's going on here? So to make it clear that we're adding a negative number, we throw in the parentheses around it. Okay? Thank you. You know, when you're not sure, that's the time to ask. Get it cleared up. All right. Let's see. Where are we? That was 15. Desk 14. Jill, did you finish this one? No. Okay. Desk 12. Who's in desk 12? All right. Cadence, what did you get for this? 176. So, do I have some confirmation? You sounded unsure.
No, I'm sure.
Okay. She's sure. Anyone disagree with this?
I thought 178, but I might be wrong.
Okay. Well, let me show you what I would do on this. Oh, well, actually, tell me what you did. I'm curious.
I subtracted 30 from 75.
All right, and got 45?
Yeah, and then I added 160 to get 205, then subtracted 29.
And then subtracted 29 from that. That's going to be 6. That is 176. That's not the only way you can do this. Okay? Let me show you real quickly that I think it's easier if you group these. Group those two together and group these two together. So I started off the same. 70 plus negative 30 is positive 45. Plus 160 minus 29 is 131. And then that's 176 that way also. Yes, Rory?
So we can make negative 29 become negative 30.
Sorry, I'm having trouble hearing you over the AC.
We can make negative 29 to 30, so it's become minus 60. So it will become 100 plus 75. And then
Then you have to add on the one more. Absolutely. You can do that, and that's a real efficient way to do it if you're doing it in your head rather than, writing it all out. That's a great way to do it. Yeah, when you can see patterns like that that give you nice, multiples of 10, it's faster. Yes.
I did mine, so I took, I did 160 minus 29.
Right.
30, which equals 101, and then I added 75.
Oh, okay. So you subtracted both of these. So you reordered them, which is absolutely fine also. Yeah, when you do that, it's like, well, that's nearly 60, so that's 101 plus 75, 176. Excellent. I like it. And when you see something like that that makes it easier, have at it. All right. So when adding the same number several times, we can multiply. For example, if the tightrope walker moved to the right 3 feet, 3 feet, 3 feet, and then 3 feet, it's shorter to write 4 times 3 instead of 3 plus 3 plus 3 plus 3. Notice parentheses are another way to show multiplication. So in addition to the dot between the two numbers to show multiplication, if you have a number in front of a set of parentheses, that means multiply also. So if we use multiplication to write 2 plus 2 plus 2 plus 2 plus 2, how many 2's do we have? So that's 5 2's. Just a different way to write it. So for the next one, how did Cecil, the tightrope walker, move if he started at point A and his moves were recorded as the expression 3 times 6.2 plus 2? Okay. So we draw a diagram for this. Here he is at point A to start with, and he moves 6.2, and then another 6.2, and then another 6.2, and then he moves 2. Well, 3 times 6.2, this whole thing so far, all of this is 18.6. Plus another 2 is 20.6. Yes, ma'am.
Can you like for 3, could you put the 5 in parentheses instead of 2?
Yes, you can. Typically, though, what we're saying here, and I think it makes more sense, is that you have 5 2s. Whereas when you do it the other way around, it has the same value, but it's like you're saying you have 2 5s. You know what I'm saying? Yeah, there's nothing wrong with it, but it can get a little confusing when you start switching them. Thank you for asking. I appreciate it. All right. So for this one way we could write this is that we've got -3 plus another -3 plus another -3 plus another -3 plus still another -3. But I could also write this as, how many -3s do I have? 5. So 5 -3s. In either case, where does he end up? -15. Yes, sir. You may. So, to represent 2 sets of 3, Chad drew the diagram at the right. How do you think he would draw 5 times -3? Well, he would have a group of -3, and he would have 5 of them. And it takes a little while to do that. So what's the value of this expression? Anybody? Just -15, yeah. Yes, ma'am.
How, like, I know it's -15, but how would you get it out of the diagram?
You just count. There's 15 negatives. Or you can say, all right, if there are 5 groups that are all the same size, that are all -3, you can just multiply. There's 15 because 5 times 3 is 15, and they're all negatives, so 15 negatives. Okay? All right. So for number 7, the 2 equal expressions, 2 times 3 and 6, can be represented with the diagram at the right. Let's draw similar diagrams for each of the expressions in parts A through C below. So, if you have 2 times 3 plus 5, so that's going to be a 3, and then a 5, and I'll try and make the 5 a little longer. And I've got two sets of those. So what's the value of this whole expression? 16. So this whole expression is the same thing as 16. So it says describe it with words and a diagram. We've described it with a diagram. In words, this would be two sets of 3 plus 5. Now let's look at the next one. They want to know, what does 2 times 3 plus 5 mean? What's the value of this expression? So this time we have two whats? Yeah, we've got two 3s. And then we have a 5. So what's the value of this? It's 11. So in words, this is two sets of 3 and then plus 5. And on this, the English can be a little bit confusing. I've had students who have said, well, I wrote two sets of 3 plus 5 for both of them. Because if you just read it, it kind of reads that way. So there's two ways that you can make sure that everyone knows that you don't mean the same thing. One of them is what I did here, and that's to say, and then plus 5. Yes?
Well, I was like thinking, like for the first one, A, like 3 and 5 are in parentheses, and then for B, 5 not in parentheses.
Yeah, and that's the difference. But we can't write it out like that in words. So the other way that you can write this in words is to say this: two sets of the quantity three plus 5. Yes, ma'am.
For B, could you write like 2 sets of 3 and 1 set of 5?
Ooh, that'd be a great way to do it. Yeah, absolutely. You could say 2 sets of 3 and 1 set of 5. That works. So when we compare these, are these movements the same or are they different? Is 2 times the quantity 3 plus 5 the same as 2 sets of 3 and a set of 5? No. So in the first one, or in the first expression, we will have 2 5s. But in the second one, we will only have 1 5. So those parentheses are important that you're careful how you read them. All right, any questions? Okay, you've got about 7 or 8 minutes still left in class, so maybe get started on the assignment or start studying for tomorrow's quiz.